All right, now we have the last two derivative sketching problems in part 4, numbers 13 and 14. Here, I only see one place where the derivative would be 0 because I have a horizontal tangent line. So I'm going to mark that spot with an X, and then on the X-axis I'll mark a 0. Now I have a clearly concave up function and a clearly concave down part of the function. I just need to find the inflection point, and I'm thinking maybe it's around there. So from that, I need to sketch the derivative. Here I have a slope close to 0, so I'll start my derivative with the slope close to 0. And then this original function is both increasing and concave up, so my derivative is both increasing and concave, is positive and increasing. So let me do that again. For this first section, the derivative starts close to 0 and is increasing and positive. So this is hard to draw in here, increasing and positive. Then for this little section, the derivative is going to be decreasing, yet still positive. So I need a turning point here on the derivative where there was an inflection point on the function. And then last, function is concave down, so the derivative decreases, and the function decreases, so the derivative is negative. So there is my f prime graph. Then last, I'm going to mark with x's the places where the function has a horizontal tangent line. Not here, this is a cusp. And then I'm also going to mark with x's wherever I have an inflection point on my original function, which would be there. And I'm going to just circle this point so we can be careful to deal with it in a moment. Now, everywhere where my function has a horizontal tangent line, I need an x-intercept on the derivative. So there are 3 of those. Now let me go section by section. The function is decreasing, so the derivative is negative, but the function is concave up, so the derivative is increasing. Let me clean that up. Okay, now the next section, the derivative will be positive because the function is increasing, and the derivative will increase because the function is concave up. So I go to here. Next section, the derivative is positive because the function is increasing. Now the function is concave down, so the derivative will decrease. And luckily, right where I had my inflection point on the function, I have a turning point on the derivative. Next section, I have a decreasing concave up function. Actually, now that I'm looking at this, I went from concave down here. There should be another inflection point in there. This is very tiny. There's another inflection point. So for this little bitty section, the function is concave down and decreasing. So the derivative is negative and decreasing right here. So I need a turning point here, and on this section, the function's decreasing, so the derivative is negative, but then the function goes concave up, so the derivative increases. Once again, I have a turning point here that matches with the inflection point on the function. Next, the function's increasing, so the derivative is positive, and the function's concave up, so the derivative increases. So looks like the function has a higher and higher slope, but then because I have that undefined spot on the derivative driven by the cusp on the function, sorry, I just had a quick interruption, so now I'm coming back. There's a cusp here, but it looks like the slope of the function got fairly high, so I kind of brought up the derivative fairly high, but then I need a jump discontinuity because I go from a fairly high slope to a negative slope right away. This section, last section, has a linear component with a negative slope, so I need to come down here and put in a constant slope that is negative. We have a jump discontinuity driven by that cusp on the original function.